This is my chemist, Frederick. He's who I will be talking about today. So, who he was in his early life, he was an English biochemist. He was born in August 13th, 1918, in Redcombe, United Kingdom, and he would later on pass away in November 19th of 2012 in Cambridge, United Kingdom, and that's kind of where he would live out most of his life. Within his early life, though, he was the second son amongst three children. His father just so happened to also be named Frederick, and he was a medical practitioner. So for Frederick, it was kind of expected for him to grow up to go into the medical field as well. His father was a religious man, and he raised all of the kids to be Quakers, which would later on influence his views on certain things that was going on at the time in the world. As he later went on to grow up, he attended Bryanston School, where for all 4 years he would stay, and that's where his love for biology and chemistry would grow. He passed his certification exam, and he was later on accepted into Cambridge University, where he would go on to study science. Due to his principles and beliefs of growing up to be the Quaker, he was greatly against the war that was going on at the time. It was just against his principles. He also, here's his wife, him and his wife right here. This is Joan Howe, or Joanne Howe, and they would get married on December 28th of 1940, and they would go on to have 3 children as well. So for his studies, he did go to Cambridge. He chose not to study medicine, as he felt like if he studied in science, it would give him a better chance to become a better problem solver with things going on in the world. He attended and graduated with the Bachelor of Arts in 1939, and he would end up staying at Cambridge to go ahead and do a PhD with Albert Newberger, who was also a British biochemist and a British professor of chemical pathology on amino acid. They were studying amino acid metabolism. In 1943, he would go on to join A.C. Chinball's group that he had going on. It was a team of scientists who were studying amino groups of like insulin. This was early on when insulin had just been discovered back in the 1920s. So they were trying to see like if they could decipher it enough to put it to use to help treat diabetes. This is a group that Sanger would join, and he would end up becoming the first person to obtain a protein sequence, actually. And after making many discoveries later in 1951, that's when he would go on to join the staff of Medical Research Council at the Cambridge University, and they would later on move in 1962 to the Laboratory of Molecular Biology in Cambridge to work and study on DNA-related problems such as like DNA sequencing, which would become an extension of his earlier work of protein sequence that he did a couple years back. Eventually, this led to new techniques that were applicable to DNA. So for the first experiment, going back to when he was studying in 1943 for amino groups in insulin, at the time nothing was really known about protein sequence of insulin or any other protein. But Frederick introduced fluorodinitrobenzene, which is also abbreviated to be FDNB. They used that to study the terminal amino acids of insulin. This reacted rapidly with insulin at room temperature to modify amino groups. The modified amino acid could be liberated from the insulin by acid hydrolysis, creating yellow derivatives of the N-terminal acid. He used partition chromatography, which was a new method to identify DNP acids in insulin. He found that phenylene and glycol are at the N-terminus of insulin. That indicated that there were 2 polypeptide chains. In order to prove that there were 2, he compared the mobilities of 2 DNP amino acids in a variety of systems on the method of partition chromatography. He decided to use the FDNB because the fluoro derivative was more reactive than the chloro derivative. He had also varied the conditions of acid hydrolysis of insulin after tagging it with the DNP. He also worked out a method for oxidizing insulin using partial acid hydrolysis. He decided to sequence he discovered the first 4 amino acids in the chain of insulin as Phe, Val, Asp, and Glu. So the second experiment goes back to when he was in the medical research group and they had went to the laboratory of molecular biology. When they moved, he started working on nucleic acid, introducing the new concept of sequencing. The only accessible small RNAs known at the time were the transfer RNAs. He began to start fingerprinting high molecular mass. The T1 ribonucleus was a adenine-specific ribonucleus, and it gave high-resolution fingerprints on a 2D modified paper system. The initial fingerprints, they had showed great resolution, separating the isomer of triclinonucleotides, such as like ACG from CAG and CUG from UCG. They were sequenced from the first principles. Their sequence decided from the isolation of smaller products obtained by the degradation with other nucleases. To sequence longer oligonucleotides, he used partial digestion, which exonuclease, and analyzed the intermediate deviation produced by ionophores on the DEAE cellulose paper in 1D. This was one dimension. This was a powerful new way of sequencing because the mobility shifts indicated which residue was present. So, current application of his studies today. People not only still use his sequencing method, but they still teach about him and his methods in school. It is said by many scientists that the Sanger sequencing method has been the most accurate kind of possible DNA. It has also inspired new alternative methods that have followed his principles, and he was able to prove that proteins were ordered molecules, that genes and DNA making these proteins should also be having an order as well. And this is a picture of him, because I feel like when we think about scientists and people who were influential, we place them in a time farther back rather than seeing newer photos of them in color, realizing that they were here for so many modern things while also being alive for those discoveries. So for his Nobel Prizes, he did win 2. He won one in 1958 and one in 1980, and they were both in the same category, which was achieved by very few. The first Nobel Prize that he won was back in 1958 for his work on the structure of proteins, especially that on insulin. The second time he would go to win again would be alongside 2 other chemists, which were the names by Walter Gilbert and Paul Berg, for their contributions concerning the determination of base sequence in nucleic acids. So in conclusion, he has provided many work and studies that have allowed us to be able to decipher genetic material which has changed chemistry today. He has had a great impact on the way that we use, study, and teach chemistry, and although today we are constantly creating new and more advanced technology to analyze amino acids or cDNA sequencing, through his experiments, he has allowed this to even be possible for us to even be able to analyze, to be able to sequence, and that has paved the way for many future chemists and probably will continue to do so. These are my resources right here, and that is all.